Welcome to Tutorial 3, Introduction to Indoor TETRA Surveys using the Aries Android app. In this video we will be looking at how to carry out indoor TETRA surveys where it is not possible to use GPS for location tracking and there may be no 4G coverage for the probe to communicate with the server. Let's start off with a block diagram. This should be a familiar diagram from earlier tutorials showing the general Aries system configuration. Multiple probes with their TETRA radio terminal are in vehicles driving around, logging TETRA network coverage data and sending it back in real time over 4G to the Aries server. Let's have a look at how an indoor survey works. So we have our probe and TETRA radio terminal, and we need to survey either inside a building or maybe underground on a metro system or tunnel. It is not possible to take a vehicle into these areas, so it has to be done on foot, and we have a walk test survey rather than a drive test. Normally the Aries probe will be using a GPS and 4G antenna for location tracking and communications. However, we would normally expect at least GPS to be blocked whilst indoors, and possibly also 4G as well, particularly in underground areas. This is going to cause problems with Aries as it must have location information to produce a map of results, and it needs 4G to set up a VQ survey and send data back to the server. Whilst the probe can manage for short periods with no 4G, it will eventually stop surveying after a long time with no connection. The solution is to use the Aries probe controller app that runs on a standard Android phone. This connects to the Aries probe using a Bluetooth link and allows you to configure all of the probe settings without having to use the server interface. For the indoor survey, you can download floor plans from the Aries server which appear on the phone screen. As you walk through the survey area, you click on your current location to mark it and set those coordinates for the survey data. As you enter more and more marked locations on the map, you create a map of the indoor TETRA coverage. In some situations, you may find that you have Wi-Fi coverage in the survey area rather than 4G coverage, and the app will allow the Aries probe to link into the phone's internet connection over the Wi-Fi. If there is no internet connection at all, then the app allows you to override the normal probe behavior that stops the survey if there is no connection. That allows you to carry out the survey, and then when you come back into either 4G or Wi-Fi service, the probe will send the stored data back to the server. The first step is to download the Aries probe controller app to your Android phone. It is free on the Google Play Store. You will also need to use a small Bluetooth dongle in the Aries probe. Insert it into the USB socket on the end of the probe while it is powered off, and then power up the probe. Let's now log into the Aries server and see how all of this works in practice. So we will log into the Aries server as usual. And I'm also going to bring up the camera showing the TETRA radio terminals we will be using. If I just make that image a little bit bigger. The first thing to notice on the normal probe and radio on the left is that we have a Bluetooth dongle plugged into the probe, and we can see the blue light from the dongle here. We can also bring up this screen capture of our Android phone. Let's get straight into using the Aries probe controller app by clicking on the icon, and we start off with the map image. The first step is to pair the phone with the Aries probe, which we do by clicking the Bluetooth icon in the top left of the screen. Click on the Scan for Devices button and we get a list of the nearby Bluetooth devices. You may need to wait a few seconds or click it several times before you see the Aries probe in the list. It will show us a device called Aries plus the probe ID number, which in this case is 2129. So I can see that in the list. I'm going to click on that. And we then need to enter the PIN code, which is 24596. Click OK. That's worked and we're now successfully connected to the probe. So the first thing to see is a familiar icon showing the current probe status at the top of the screen. Green shows that things are okay, red indicates a problem, and these are the same icons that are shown on the server for each probe. We can click on the target icon in the top right to take us to the current location given by the probe GPS. And we can see the events on the map at our current location in the UK on both the app and the server map. The map layer control just below that allows us to select the map type. and we'll come and take a look at these other options later on. At the bottom of the screen we have the Event Pull-Up tab, showing the events being logged in real time. Just click on the map to remove that. And in the far bottom right corner, we have the map legend showing the event icons and colour key. Lastly, we have the probe settings button below the Bluetooth button. Clicking this takes us to a number of tabs with the same parameters for the probe that we've already seen on the server. We have the General tab, the Network Settings tab, the Event Monitor Rate, the VQ settings, and so on. There are a few new parameters that we will need to use for an indoor survey. They are the location source, where we can set to use probe GPS only, or use phone GPS only, or use a mixture of the phone GPS and manual location, or use manual location only, which we will need to use for an indoor survey. But we'll come back to that later. The other new options are the Ignore Paired Probe Check, which allows the probe to start VQ surveying even if it does not have a connection to the server. Then we have the Don't Restart on GSM GPS No Coverage, which is very important for indoor surveys where this is likely to happen. Finally, we have the Use Bluetooth Tethering, which allows the probe to use any internet connection that the phone may have. At the top of this page we have the Submit button, which needs to be clicked after making any changes. Plus we have a Probe Restart and Power Off button, which can be very useful. We're now going to carry out a demonstration indoor survey. The radio and I will still be staying right where we are at the moment, but I will be clicking on the map to set our location as though I was walking around the building. The first step is to create a floor plan of the building. We're going to simulate a survey of an airport, and I have a floor plan here, which has been georeferenced and saved as a GeoTIFF file. That just means that it includes coordinates for the image corners so that it can be displayed on a map in the correct location. If we zoom into the original file, we can see it shows the airport departures floor. The first step is to now import this into the Aries server as a raster overlay. So I'm going to move that to one side, and we'll go to the server screen, the admin page, and then select the Map Layers tab, and then the Raster Layers tab. Firstly, we need to create a layer to hold the overlay. Let's call this Airport. And then we need to add a new overlay. So we'll call this Departures. It's on the Airport layer. We'll select the file, the Departures file. There's a transparent color if we need to use that, and the opacity, I'm just going to set that up a little bit higher, and then click Submit. Once that is loaded, we can then go to the map and enable it from the map menu layers on the right hand side. Then if we actually zoom to where the image is, it's actually Athens Airport, so we'll zoom right in to this. And we can see our map image clearly overlaid on Athens Airport. The next step is to download that to the app on the phone. So let's just move the phone back to the center. So we click on the Map Layers button and then the Add Overlay button. And we need to enter the server URL and login details of your normal user account. I've already entered my details. We click Submit, And we can see the list of available overlays, in this case just the single overlay, the departures file. So we're going to click on that. And it shows downloading file. And go back to the map layers. And we now have a map layer for the departures. So I'm going to click on that. And we'll go from our current UK location all the way to Greece to see the image on the map. There we go, the same as the server screen. We can now see on the phone screen the same map overlay. We do have another option for this building and some other major public buildings around the world which have uploaded their floor plans to Google. If we go back to the Layers menu and click Indoor Floor Plans, I'm going to unclick our floor plan and then back to the map. We can see the floor plan of Athens Airport together with a floor level selector, which makes a very easy way of getting a floor plan, but they are only available for a small number of buildings around the world. Let's go back to our own floor plan. So we're going to turn off the Google floor plans, click departures, and there we go, back to our own floor plan. We now need to set the survey probe parameters, and I'm going to remove the GPS and 4G antenna connection from the probe to simulate us being indoors or underground. So now the probe doesn't have a GPS or 4G connection, and we need to go ahead and set the probe parameters for the survey. So I'll click on the configuration button and I'm going to set GPS to use manual location only. I'm going to tick the ignore paired probe check. This is because the probe cannot contact the server to check the VQ transponder probe. It is important that you've used the probe together with the VQ transponder earlier to make sure both probes had the same survey configuration. I'm going to tick the don't restart on GSM GPS no coverage. I'm going to set the monitor rate to 3 seconds so we get more detailed signal measurements. And finally, I'm going to tick the VQ enable box. And then we click submit. And we can see immediately that the GPS icon at the top of the screen has now changed to indicate that we're using manual measurements. The first thing to do is to move the map crosshairs to our current location on the floor plan and click the crosshair. So I'm going to zoom in on the map and we're going to pretend that we're standing in the airport departures area, and we click on there and we set our location. It's drawn a line from our previous location, which of course is in the UK, to this location. So I'm going to get rid of that by clicking the map layers and click on the clear markers and path button. And now we can imagine that we're walking slowly around the building and setting our current location on the floor plan under the crosshairs and each time clicking on the button. As a general rule, it is a good idea to walk in straight lines and set the current location when you change direction or stop or start walking, ideally at least once per minute. During the survey we can see icons appearing on the map, but only at the locations we have marked. That will change once the data has been uploaded to the server. So I'm going to go ahead now and take a short time to mark out a survey route as though we are walking around the building. So that is our survey finished, and I'm going to go back to the probe configuration and disable the VQ testing and set the monitor rate to 0. That's a quick way of stopping any further events being logged without actually powering off the probe, so that we can allow the data to be sent back to the survey. Click the submit button. All of the survey data is currently stored on the probe, so now we need to simulate coming back into 4G coverage by reconnecting the probe antennas. We can see now that the probe has regained its 4G connection to the server and is sending the stored data to it. Let's check the server map screen. So I'm just going to move that to one side. I've already configured it to show data from this probe, so we'll see the data coming up on the map, and already we can see that there. So the server has already interpolated the data between the points that we set to produce data that's evenly spread along a straight line between each marked location. And there we have it, the final survey data correctly following the route we took walking around the building. We have both monitor events and VQ events. As usual, we can click on a VQ event and even play the speech sample.
Canada was established only in 1867.
So that completes this video on indoor surveying using the Aries Probe Controller app. I hope you found it useful, and please do check out the other Aries tutorial videos.